very good morning, everyone.
Morning, Doctor.
Where is the recording? Okay. Right, so as usual, the session is recorded. Okay, so welcome back to basically the official first class of SEMO3523, Integrated Ship and Offshore Design Project 1. Yeah. Okay, so let me just proceed with Okay, let me just I'm not sure whether because this morning when I um go into the upper MSWEP UTM and look for the student name list, and there's a additional of 7 more students, I think. But last time it's about no. Last time it's about 37, so now we have 39. Then plus with uh, Erisha, and I think one more uh, members who still not register for this SEMO3523 teenage. So we're supposed to have 41 of you in the class, yeah? So usually 41 we split into 2 sections, and more than 40 we split into 2 sections. But I'm not sure the current practice of a school, yeah, so we still in 1 section lah. But nonetheless, even the 2 sections we still run as 1 section lah, so all sections in 1 sessions. Okay, and I can see some name here who are not present uh, in the last class on the course briefing. So let me just go through a little bit, but not detail on the course information. You can get this course information in the e-learning, for those who just joined today class. You can get this course information in e-learning. But I know e-learning is down today. So then I also cannot upload anything related to the class today. But I'll share in the WhatsApp group later on. Any documents or informations related to SMO3523 lah. Okay, but later when you can access the e-learning, please find the course information and keep with you, so that throughout the semesters, this is one of important documents that you have to refer. Okay, so just a brief on this one. Those who just joining today, one important information that you need to be that you need to understand is actually the course learning outcome and the PLO basically. So you need to be brief with this course learning outcome, so that by the end of the course, or throughout the course, you have the expectation of what you have to do, what kind of assessment that you need to submit. Okay, so all that kind of assessment and course learning outcome should be understand before you start doing any project, or you start doing any assessments lah basically. So I'm not going to go through this course learning outcome. We have go through this one on in the last class. So I think I also have shared the Webex recorded link for the course briefing in the e-learning as well. Okay, so please go through when you have time and listen to the course learning outcome, the explanation on the course learning outcome, the assessment, and so on. Okay, so we have here 6 course learning outcome, basically addressing the THDS here. PLO is basically the design, design development, and then PLO2 here is more on the problem solving skills. And then you have this SCMT is on modern tools. Then CS here, PLO9 is communication skills. 10 is teamwork, and SC here is on the lifelong learning. So here, this is all the PLO and CLO that you need to be able to obtain by the end of the course. You have to be able to develop a design, you have to be able to solve problems given to you. Yeah, you have to be able to utilize modern tools. Then communication skill here in terms of report writing, yeah, or maybe a presentation. But here, because the PR here is project and PR small here is for presentation, so we may or may have not our presentation. Okay, maybe just a comprehensive design report. Then we have a project portfolio and peer assessment. So all this assessment already addressed in the course information. And so if you do not submit the project portfolio or a project, so basically you do not do any kind of assessment to allow for any grade to be given to you. Okay, so please understand all this course learning outcome. Yeah, so from this course learning outcome, you can expect what kind of project that you're going to do in this SEMO3523. Okay, um, then you can go through this weekly schedule also, but it is not exactly what displayed in this course information, meaning to say hull form design and hydrostatic properties, yeah, selection of basis ships. Actually, for those who come from SEMO3512, some of the group already select the basis shape. Okay, but of course, we're going to do some recap on how you're going to select the basis shape. Yeah. Um, then okay, I cannot use that. Like I said, yeah, because those who not attend last course briefing, you do not hear what I said last time. Okay, some of it, if you look at here, we have hydrostatic properties. Yeah. Um, so for those who attend last class, so you heard what Dr. Xiao and myself said, or for those who just joining, this SMO3523 is a shared or team teaching subject. So the first half will be taken by me, and then the second half will be handled by Dr. Xiao. Okay. So let's say for the hydrostatic properties just now, so we are not going to go through the lectures on hydrostatic properties, yeah, because this is what you have learned in uh, Naval Architecture 1 and Naval Architecture 2. So same with the hull form development using the design software, yeah. So hull form development using design software, you have gone through the process in three, I cannot remember the code, but it's a ship and engineering drawing. Yeah. Um, for SKMO, I'm not sure whether you have gone through the same curriculum where you use Rhino for the hull form development in ship and engineering drawing. I don't think you have it because that one is for new curriculum. Yeah. But of course, yeah, we will have a session for this hull form development using design software. But it's up to you. If you have the knowledge of Rhino, for example, you can utilize that skills, yeah, to develop your hull form. But in this session, I'm going to use, or I'm going to focus on the MaxSurf, yeah, for hull form development. Because when you use hull form development, you can directly check for your hull form properties, and then you can use for stability calculation and also assessment. Okay, but we can do the same as well from Rhino, meaning that from Rhino you can uh, export, okay, and then you can open in MaxSurf to do the hydrostatic hull form properties and so on. Okay, but in this SMO3523, I'm going to focus on MaxSurf software. So related back to the course learning outcome just now, we have that course learning outcomes on modern tools. Yeah, meaning to say the assessment will be assess, yeah, your ability or your applications on modern tools ataupun software lah basically. Okay. So you need to be able to show that you have the skills or you have given the knowledge, yeah, to use the modern tools. Okay. So that hydrostatic properties, and then same for stability. Yeah, so you have learned all this stability knowledge on naval architecture 2, if I'm not mistaken. So now you apply that knowledge that you have learned in naval architecture 2 in integrated ship and offshore design project. So that's why we call it integrated, yeah, because it's integrated, not from Naval Architecture 1, Naval Architecture 2, and your ship engineering drawing. And later on, we will have this structure assessment on IDP2. Yeah, so basically you have learned that one on ship and offshore structure. Yeah, so that's why it's called integrated. Okay. So this is this weekly schedule is what you have to you expect, yeah. Meaning to say you have first interim project, you have second interim, and then you have third interim project. Okay. And I think in the last course briefing, I said that we have 3+1, meaning to say that one project is on the offshore. Okay. But pardon me for that mistake because now it is integrated. Yeah. The offshore part will be appear on second, yeah, integrated ship and offshore design. So integrated ship and offshore design 2. Um, the next semesters, next semester, so you will have integrated ship and offshore design 2. So in integrated ship and offshore design 2, we will have the structure. So that is basically the integrated from ship and offshore structure 1, ship and offshore structure 2. Okay. Then the second half of the semester for that IDP2 is focusing on offshore part. So you will have this offshore calculation hydrostatic, you will have this offshore stability assessment and so on. Okay. So for SEMO 3523, we will only have 3 projects basically. Okay. So 3 projects plus portfolio and plus test. Yeah, so basically we have 2 tests. Yeah, 2 tests. Then technical report. We will have 3 technical report. Project portfolio. Project portfolio is basically one portfolio lah from the first project until the last project, the third project. Yeah. And then apart from that, we will have the peer assessment. Okay, where you assess the contributions of each group members to the project. Okay, so the rest you can basically refer to this course information lah. Okay, so is that clear for course information?
Yeah, Doctor.
Any question related to that one? No, I guess. Okay, right, no so far. Okay. Yeah, I'm searching for and find this PDF file. Where is my PDF file? Just now? Design group. Okay, so for today we will have a recap on the design process. But before that, yeah, I would like to announce your design group, basically. But just let me find the design group first. I mean the design tasks. I opened it just now, but I cannot find the. Okay. A second, yeah. Give me a second. This one. Okay. Oops. This one it says SEMO3512. A second, I cannot find the. Oh, this one is also the same. Okay. It's there. Oops. Oh no. Give me a second. Okay, so basically SEMO3523 is a continuous from SEMO3512. Yeah, so basically, yeah, especially for those coming from SKMO, uh, it's not that I want to apa tu, dia panggil apa, um, apa tu, some kind of racism ke apa, but I need to address lah for that, for those who coming from SKMO, yeah, because you have actually skip the first step in design process, which is the main dimension, yeah. Mashallah. This one, yeah, okay. So this one, design instruction. Okay, but this one I'm going to explain on detail later. Just let have this. So yeah, because just now we have this apa, so basically because SKMO and SEMO the curriculum is a little bit different, yeah. So but then um the what we call, the director of the program say that okay, it's okay, just proceed with the IDP 2, sorry, IDP 1, okay, for SMO as well. So now then we have to apa tu, rearrange the groups lah basically. Sekejap ya. Okay. Give me a second. We have to rearrange the group, uh, and some group will have 4 and some group will have 2, 3 persons, yeah, 3 group members. Okay, right, okay. So just let me brief on the design of SEMO3512. Yeah, this one is specifically for apa ni, for those who SKMO lah. Yeah, because you have skip this part, yeah, of designing process of ship. Okay, so basically the design process, they start with an owner requirements. Okay, so you are given a requirement, say that what kind of ship, yeah, how many speed, and then what is the dead weight, yeah, how many dead weight. So then um, based on that owner's requirement, then you come up with the mean dimension. Yeah, so basically the length, the breadth, the depth, yeah, and then also the draft. Yeah, so basically the LBDT. Okay, so all these basically have been calculated. Yeah, this is all the steps. Yeah, so based on the owner requirements, then you calculated the LBDT. Yeah, and then the CB as well, the block coefficients. Okay, the appropriate mean dimension based on the owner or design requirements. Okay, so these are the owner's requirement given for every group. Okay, so basically last time we have 12 group, but then because of unfortunate circumstances, so we have only 11 group left. Yeah, so basically this SMO3523 will have 11 group, with some of group will have 3 members and some group will have 4 members. Okay. Um, then so based on the ship type, based on the DWT or deadweight tonnage, and based on the speed, yeah, so the group must find or calculate the appropriate mean dimension. So that what have we done in SCMO 3512. Okay, so in the next week we will have one slot, Yeah, basically to recap back on the main dimension. Yeah, so I hope for those coming from SKMO, please attend next class, yeah, on Sunday and also on Thursday, so that you will have a knowledge of how the main dimension is calculated or determined. Yeah, and for SKMO student, yeah, unfortunately, you will have extra assignment, yeah, to address these main dimensions that have been calculated in the previous HMO 3512. Otherwise, there are some missing elements in the ship design that you not do. Okay, so that is a remark lah, yeah, for those from SKNO. So you have additional assignment, yeah, by next week on the main dimension. Okay, but later on, when I assign you to the design group, yeah, please get the previous design report from your group and go through the owner's requirement, go through how your group members determine the main dimension and what are the main dimensions that they get from last SMO 3512. Okay, for those from SKMO, so please get the report and go through. You have to do some extra work lah, because um, the curriculum is a bit different. So uh, we cannot open SKMO 3523 anymore. So because it is the previous curriculum, so now we only have this SMO 3523, and to address the main dimension, so we have to give you extra assignment and you have to do a self-study lah basically. Okay, boleh ya? I can see Anas, Ashraf, Atira ada tak kat sini? Atira, Amar, um, dan siapa lagi saya ingat tadi? Boleh doktor. Alright. Okay, the report is actually in the e-learning. But if you cannot get the report in the e-learning, contact lah the group members later on. Okay, this one also I will put in the e-learning, and we will recap this in the next week, because this one is more on the main dimension, okay, which we will cover next week. And for all, please get back your Watson book, yeah, practical ship design, and also Papan book. Yeah, this is for additional reference lah. Yeah. Okay. Then basically this is your design group. Okay, so we have 11 group. Okay, of course I'm going to share this one later on. Okay, but just let me explain this column leader. Okay, because last time on SMO 3512 we don't appoint any leader. Okay, but this one is up to you. I mean, if let's say Daniel do not want to do project 1, then you can change lah within the group. Okay, so P1 means that you are the leader for project 1. Okay, P2 is leader for project 2 and P3 is leader for project 3. So project 1 is basically on hull form and hydrostatic. So you develop the hull form, not you develop yourself, but you are the leader. So you leading the group, yeah, to do all the design tasks later. Okay, so you have to make sure that your group member attends the class, the studio session, yeah, or if you have a group discussion, so you make sure all group members attend, and then you have to make sure that there are progress every week, yeah, with the design tasks given to you. Okay, until you finish the first project. Then the second project will be led by another group members. Okay, why? Because this is actually, if you look in the CI, we have this teamwork. Yeah, so we have this teamwork. Yeah, work in team and manage the schedule effectively in carrying out the design project. Okay, so we think that it is not fair if only one person become the leader throughout the semester from project 1 until project 3. He or she is the only leader. Okay, so to make sure that is fair for everyone, yeah, so we decide to do like this. So every project will have a different leader. So meaning to say, if let's say you do not submit project 2 or project 3, then the blame should be on the leader. Okay, do I make myself clear on that one?
Clear Doktor.
Right. Okay, I think that will be fair enough lah. Otherwise, some group members will only become a free rider. Then at the end, you still get the same marks as your other group members. Okay, so but this leader, yeah, the project leader for every project, it's up to you if you want to change, but let me know. If let's say Daniel say that I want to become the project leader for project 2, okay, so then you discuss among yourself. All right, thank you very much for the questions. AR means all rounders. Okay, so all rounders, meaning to say that your task is actually specific to assist the leader and to remind the leader on his or her role and responsibility as a leader. Okay, maybe let's say some of the leader for, let's say, project 1, he forgot that he is a leader. There's no progress at all for every week. So you as a all-rounders, you are a versatile person with many skills. Okay, I can rely my hope on you to assist the leader. Yeah, but you are not replacing the leader. Yeah, you assist the leader, you remind the leader. Leader, you should do this. Yeah, we should have a group discussion. We should submit this report by this deadline, for example. Okay, but you are not replacing the leader. But of course, every group member must do the design task, not only the leader. Yeah, leader is only leading the group. Yeah, not leader do all the works lah. Yeah, that is not the correct words of leader. Okay, so leader, they must bring all the group members. Yeah, and do all the design tasks together lah, basically. Or you can assign for project 1, what is the task and so on. So assign to these members and so on. Okay, but all rounders, you are specifically to assist the leader, to remind the leader on his or her role and responsibilities. Okay, AR cannot be changed. So AR is specifically not appointed as a leader, because otherwise some of them is a good leader already. Yeah, so we need to give the others opportunities to become a leader. Okay, so you can see this design group later. I'll share on the WhatsApp group lah, because the e-learning is not working at the moment. Okay, so you can see some of the blue one is actually the additional from SKMO. Okay, so some group will have 4, some group, those who don't have, only have 3 groups, so you don't have the all-rounders, basically because you are good by yourself, yeah. But some of, because to assist lah, especially in the group. Okay, so P9, oh, only this one, yeah, group 9, I'm not sure about Tinesh, he's still not registered for SEMO3523. So at the moment, you will have 4. If Tinesh not registering for the SEMO3523, so basically you have 9 lah. Okay, so there's no all-rounders in group 9 yet. Okay, then that will be it for the design group. So any questions? So I know some of the group, there are some issues with the group members and so on. But it's a challenge actually. You need to try to solve the problems. Yeah, either you can remind the group members. But if let's say you have given a lot of reminder but still no response and so on, yeah, please come and see me or Dr. Xiao so that we can try to solve the problems lah. And for all group members, please give your full cooperations to the leader. Yeah, because that is also one of the reason why we give different leader for different projects so that you can taste, yeah, the sweetness and the bitter of become a leader. Okay, your group member does not give full cooperation and so on. Yeah, so then that uh, help you to develop the skills of a leader and also a problem solving skill as well. Okay, so I suppose there's no questions. Everyone is happy with the group because you don't do any design tasks yet. Yeah, so you are happy now. But then when you do design tasks, then some happy and some will become. All right. Yes. Okay. Thank you very much, Arif. Okay. So right. Okay. So then that one is for design group. Okay. Let me just proceed with the teamwork. Yeah, because we are speaking with the teamwork elements. Yeah. So this is for teamwork. Okay. So as usual, as the last practice on ESMO 3512, okay, you have to fill in the group policies. So once again, this group policy will be put, I suppose I want to put it in the e-learning today, but unfortunately, let me just show you the group policies, but it should be the same as previous group policies. Give me a second, this is not in PDF. Okay. Oops. Okay. It's my PDF. Group policies. Okay, so this one should be the group policies, same like the previous group policies that you have. So put your group numbers and the name. Yeah, you can carry the same name as the previous group name. Put the group members, yeah, A, B, C, and additional four. You have to add this one later on. Group mission or goal. Yeah, what is your mission? What is your goal? Okay, and you have to plan one group meeting time. Yeah, this one is outside of the class. Yeah, basically outside of the class, not during the class time. Okay, just like my course briefing last time. Let me just open it again because some of you did not attend last time. Okay, so basically this one, yeah. So your student learning time should be 120 hours per semester. Okay, so basically your design class is 5 hours, so you have another 3.6 hours to work at home. So basically that 3.6 hours is including your group meeting time. Yeah, so you have to plan for one group meeting time or maybe two, but one is enough. Yeah, for every week you will have this group meeting time. Okay, please find one day, what time, yeah, durations, maybe 1 hour or 2 hour is enough, yeah, and the venue now should be online. But if you are in UTM, so maybe you can plan for a face-to-face meeting lah. Yeah, doesn't matter. Okay, but you need to have this one or two group meeting time every week. Yeah, and for every meeting time, you have to prepare the minute of meeting. Okay, last time, I'm not sure whether you have it or not. Do you have this group policy last time? Ada kan? But you don't submit the project portfolio. I mean, you don't have project portfolio last time. Am I correct? Or do you have the project portfolio? Ada. Sorry, I cannot recall that one. Okay, ada. Let me just, uh, I cannot recall. Oh, yeah, yeah, okay. Yeah, yeah, that one. Okay. See, so this one is an example of group 2 last time. So you can just carry on with the same group mission, but maybe you have additional group members. Okay, so this one is 1 hour. This is not 1 hour. This is 2 hour, 8 to 10 a.m. Okay. Um, okay, and then go back to this one, but the same one. Yeah, so group policies, group rules. Yeah, be punctual. Each member must participate actively whatsoever lah. You cannot bring say majority vote, veto, other opinion in problem solving discussion. So whatever policies or rules that you think you need to implement for the chip design. Okay, and must be signed by all members. If you have four, please add another one here. Okay, this is basically for the the ni lah portfolio. Yeah, this one is for portfolio. So meeting details here. So what are the summaries and so on. So this kind of meeting, minute of meetings. Yeah. So for every minutes of meeting, you should have. Yeah. This one meeting details and so on. All right. But this one ni dia tak. It's not too many meeting details. So every meeting details, you should put the minute of meeting. Okay. Sign and so on. Right. So then that will be your group policies. So then that group policies, okay, will be submitted later on. Uh, Last time you have these policies, so you can just use that one lah. No need to submit for approval, yeah, because already submit last time, right? Then whatever design sheet, yeah, you do for calculation, for discussions, for reading or anything related to the design work, yeah, you must record. Yeah, later on you can scan the design sheet and then you can put in the profile as well, portfolio as well. First questions. New teammates, ni lah, meaning the group policies should include the new teammates lah. Yeah, should include the new teammates, should get approval of the new teammates, sign of the new teammates. Yeah, but basically the group policies, group mission, group goals, and so on, you can use the same as the previous one lah. Okay. So group policies, group portfolio is based on all the design tasks that you're going to carry on later. Okay, all these distribution tasks will of course will be different lah. This one is based on SEMO3512. So now this Gantt chart, this distribution tasks and so on will be based on SEMO3523 lah. Okay, with additional of another group members. Alright. Okay. Clear, yeah. Okay, where am I just now? Okay, that one. Okay. Last time, did I give you the project summary sheet? I think I gave you that one as well. Or not. Let me remind me this one. Project summary sheets. This is the project summary. Some of group, they submit this project summary. But some of group, you just submit a kind of summary, but it is not the summary sheet that I give to you last time. Okay, this is a project summary sheet, basically. Yeah, so job description. So it's actually the job distribution task lah. Okay, what is the job description that you do? Who done it? Yeah. What is the duration, date, and category? So category can be design, it can be calculation, it can be report preparation. Okay, it can be the other one lah. Design tasks, calculation, assessment, report preparations, report writing, and so on. Okay, so this summary sheets will put all the job descriptions and who done it. So from this summary sheet, we can see who actually do all the works lah, basically. Okay. This is one kind of a team working assessment as well. Okay. Yeah, job category is here. Design, calculation, analysis. B is for drawing or drafting. C is literature finding or reading. D is discussion, meeting, consultation. E others. Yeah, others is basically more on the report preparations lah. Okay. So you're supposed to put together these project summary sheets in your project portfolio. But this one is only at the end of the project. Project, yeah. So we have project title, project one, lead by whom, okay. Then what is the description for every task to complete the project. So then when you go to project two, same, you will put what is the job descriptions, who done it, and so on. Okay, so we can see who actually do the job and who actually a free rider in the group. Okay, so by having this, so we as the lecturers, we can know, um, and from that we can actually assign the mark for team working part. Okay, yes, some of tasks, maybe let's say drawing, it require more than one person, yeah, for that one. Okay, so basically drawing, everyone need to draw. That one I'm going to brief on, I think it's week 3, or maybe week 2 lah, maybe week 2. Because week 3 we already start on half form, so maybe by next week or early of week 3, I'm going to brief you on the half form design. And so, but basically um for every remember last SEMO3512, so every one of you calculated your own main dimension, right? So same, the half form design, we're going to develop your hull form based on your own main dimension. So basically, if let's say you have 3 of you in the group, so basically you will have 3 different hull form. Yeah. I don't mind if let's say only one person do the drawing, but then the 2 of you just copy and you change the dimensions. Doesn't matter. But then that is actually the cons lah, basically. Yeah, the weakness of you doing that one. You don't get the knowledge of using the design software, which is actually crucial. Yeah. Most of your seniors, when they go outside, they say that I use this a lot. I use this Maxsurf, I use this Rhino a lot. So if you're not getting the knowledge now, then rugilah, basically. Okay. Um, Having 3 drawings will also let us see that one person, they can come up with a very good drawing, a very good half form, but another maybe not so good half form. Okay, so that's why each of you need to develop your half form. Okay, but later when you do the hydrostatic properties, okay, we will see this one on week 3, but just let me just give a brief on that one. So 3 of you or 4 of you will develop your half form. Okay, but for hydrostatic properties, you can run in the Maxsurf directly. You can get the hydrostatic properties, but there will be a checking of the hull form properties or hydrostatic properties. Then for that checking or verifications, you need to do a manual calculations to get the to get the LCL, LCB, to get the KG, KMT, whatsoever that you have learned in Naval Architecture 1, yeah, hydrostatic properties. That calculation for verification of hydrostatic properties can be done one only per group. Okay, so the rest just following the same um, manual calculations lah, basically. Okay, so same with the stability assessment later on. For general arrangement design, 3 or 4 of you need to come up with your own GA design. Because maybe one person, he want to have 3 per deck crane. But the other person, maybe he just say that I just need to have 2 because my ship is a little bit smaller than you. Okay, so it will be a little bit different in terms of GA. Okay, but then when we go to stability calculation assessment, okay, we can also we can only one calculations only. So you pick the most uh, what we call comprehensive design and most comprehensive GA design. Then based on that person, a half form NGA, we do stability calculation assessment. Okay, so some part, all of you need to come up with your own design. Some part, maybe only one representative lah, basically for per group. Okay, so back to the question just now. So some job category, you can have more than one persons. Yeah, literature findings, maybe not only one person, maybe two of you can do literature finding as well. Okay, so same with the calculation and analysis. So it's up to the leader to distribute the tasks. Okay, right. So all the above sheets or forms will be part of your project portfolio. Yeah, and if we go back to your assessment. Okay, last time did I show you the assessment? I think yes. Um, so back to the assessment. Yeah, so for project portfolio, it's uh, it's 8 marks, yeah, plus peer assessment. So it's a free 10 marks, yeah, basically for portfolio only. Okay, so if you do not submit the portfolio, yeah, um, with the required content, yeah, all this design sheet, all this project summary sheet, and so on. So then you lose the 10 marks, yeah, the free 10 or basically free 8 marks lah, basically. Okay, so this is the new assessment, yeah, but the marks can be apa ni change. Okay, so we will have 3 project, project 1, project 2, project 3, test, portfolio, and peer assessment. So this is a free 10 marks basically. Yeah. 10, maybe 9, maybe 9.5, yeah, according to the peer assessment, basically. Okay, but it's a free 10 marks lah. If you submit the portfolio with all the required documents and you contribute to all projects, yeah, then your peer give you full marks for that team working elements, then basically you will get 10 marks free for that one. Okay, so project 1 will bring 35 marks, project 2 on GA will bring 20 marks, and project 3 on stability is 25 marks. Yeah, but we still try to balance between project 1 and 3, 30, 30. Okay, so you can estimate this as 30, 20, 30, sorry, 30, 10, 8, and 2. Okay. Of course, all the rubrics will be explained later lah when we go into the project itself. But for your knowledge, this is how the marks distribute. Okay. So if you're responsible for project 1, to get that 30, okay, you need to be able to submit lah all the project report, project portfolio. Yeah. So every portfolio, sorry, for every project you will have one portfolio basically. Okay. So then this is where that 3 coming from. Yeah. Work team. Okay. Right. Any questions with related to this all this apa tu administration part? All the documents will be uploaded in the e-learning. Hopefully by end of today maybe the e-learning, yeah, it's working at the moment. Okay. So it's working at the moment. Um, right. So I'm going to upload all the documents in the e-learning, yeah. Okay. Any questions? No. Sorry, this one is not topic 1. I'm trying the e-learning at the moment, but I don't think it's working at the moment. Editing. Yeah, okay. Some tool. Let me just put this design group first. Then the rest I'm going to put together, yeah, the group policies, the project summary sheets, and the rest. Team working instruction. Let me just put this design group first. An error is occurred. It's not working. Okay, never mind. Okay, so then that's about it for the group formation. Second, this one. Okay, so if there's no questions, then I'm going to proceed with the next activities. But this is more like a recap lah. Recap, yeah. Just to recap back all the knowledge that you get, or for those who coming from SKMO, this is basically ship design. Okay, I have put a Jamboard link in the chat box. Okay, so please go to the chat box. Sorry, chat box pula apa? The Jamboard. Okay, I just like to recap your knowledge. Okay, or maybe your knowledge, not a recap, but maybe your knowledge on ship design. Okay, so please put what do you remember or what do you know, yeah, about ship design process. So you can use this sticky note. Yeah, you can use this sticky note at the left part, or you can put text box here, or if you want to use this pen also you can use, yeah, whatever it is. Okay, what do you remember or what do you know about the ship design? So we have 33 of you here, so I expect 33 response. 33. For those who coming from SKMO, please let your friend know sebab saya takut ada yang tak buka e-learning ke whatsoever, yang tak join the group. WhatsApp group tu ya. We have the WhatsApp group, so please ask your group member to join the WhatsApp group. Because link to the class I usually put in the WhatsApp group. I don't put in the e-learning. They said the access to the e-learning dah perlu, but I don't think dah boleh. Just try this one. Okay, now it's dah boleh. Tadi tak boleh. What is it? What is it? Just say the group WhatsApp name. The group name is SEMO3523, right? Ship Design 1. I already changed the WhatsApp group name to 3523. but it's ship design one. Last time is ship design, I think. SEMO3512. But I think it should be 43 participants. So minus myself and Dr. Xiao, so should be 41. So I think everyone is already in the okay. And I don't think you have this apa? Hari tu Atira je yang ada clash, but Dr. Xiao informed me that he already changed the apa tu? The time for apa? Saya tak ingat. Semisap je. Sem 2, 21, 20. Ah, never mind. Okay. Do we have 333? Okay. What is papan book? Okay. Right. Let's just take a look of this design process. Okay, fun process, design spiral, okay. Okay, iteration process in determining length and all the difficulties to change the ratio backs. Okay. Finding mean dimension, three methods: weight calculation, capacity, cost estimation, GA drawing. Wow, okay. Right? To determine the mean dimension, we have three methods, but that one we will recap again. Thank you very much. Calculated L, estimate L, trial L, yeah, for knowledge from SKMO. Okay, but we will recap back in the next week for mean dimension. Do not worry. A big fun here. Are you sure you're having fun designing the shape? All right. Okay, stability, capacity, repetitive process to obtain optimal dimension. Okay, spiral process. Okay, design and build. Okay, let me just find. Okay, so you have to keep on altering your mean dimension until you get the ideal or basically um, the appropriate mean dimensions. It's all fun until finding the reference section of paper for design report, right? Okay, but that is actually a practice for you because when you go to the fourth year, you will have this apa tu UGP, undergraduate project. Then that will be more. Yeah, you have to find a lot of reference, a lot of journal paper, yeah, for your UGP. Believe me, yeah, some of your seniors here, those who from SKMO, maybe they have go through that process. Yeah, uh, to start with the UGP one, yeah, you have to at least for my students, yeah, for students under my supervision, you have to at least give me 10 reference, yeah, and that reference should be reliable reference, a journal paper, a books, not from website. 10, yeah, 10. You can go and ask my students. Yeah, it is the process, yeah. You cannot just that upper knowledge coming from anywhere, yeah. It should be coming from a reliable resource. Okay, to give explanation to people in easier form. Okay. Yes, no correct or wrong, only suitable or not. Yeah, same with all the process that you're going to do later. Yeah, the ship, the hull form development, the hydrostatic. Yeah, there's no correct on that is the hull form. This is the correct hull form that you should draw or you should develop. Yeah, there's no like a correct or wrong. Yeah, but it's more like appropriate, suitable or not. Yeah, there's no correct or wrong in design. Yeah. Require intensive research to obtain reliable and accurate information. So this is more related to this one. Okay. Right. Okay. It was a tedious work. It took a lot of study. Can you see this one? You can see it. It was a tedious work. It took a lot of study, research, do trial and error to complete the final project report. Though the knowledge is powerful and worth. It helps me a lot to understanding that designing a ship. Okay. I thought will take a lot of process. Yes. Okay. So this is actually a reminder for you once again here. that the ship design is a tedious work. So same, whatever that you're going to face after this, maybe today, week 1 and week 2 is okay, you still can chill a little bit, yeah, you can relax a little bit. But when you start doing the design tasks on week 3, basically, so you embarking into a journey of a tedious work, right? Uh, but it's a bit more easier lah because you have passed that main dimension part, basically. Yeah, the main dimension part is tedious. But then you're going to face a more tedious work on IDP2, on structure. I'm not going to be around when you do that. Okay. Maybe Dr. Xiao will lead you in that one. Okay. So please, yeah, a very good comment from our friends here. It was a tedious work. It is a tedious work. It was in the past, but the design process is a tedious work. Yeah, it takes a lot of calculation. It takes a lot of information. Yeah, information searching and information sharing. Yeah, to develop or to design a ship, basically. Okay, right. Thank you very much. No room for error. No lah. There's actually a room for error. I mean, you have like 5% or 6% of margin, right? Yes. So if there's no error, no room for error, means that you need to have that correct main dimension. So there's no there's still a room for error. Governing equation. Thank you very much for that governing equation. So you have to hold this governing equation until your IDP2 later on, next semesters. Okay, but you have to hold these governing equations. Don't worry, for those coming from SKMO, we're going to look into what is this governing equation next week. Okay. All right. Is this 30, 33, 10, 20? Yeah, it's about 33. But maybe some of you put 2 response, but it's okay. Okay. What do you remember about Papan books? Okay, what is this? I think this is a new ship design is a fun and game until you cannot get the information you want online. It's get to you sometimes. Okay. But there's always apa tu, a way to solve these problems, right? You can get from Papan books and so on. So do not worry much. Okay? If you cannot get the correct apa tu information that you want, let's say the lines plan, you can always use any lines plan. Then we can alter it when you develop the house form. Do not worry much. Yeah. Previous designers, they actually start from scratch. So there's no like lifespan that they can refer to. So do not worry for that one. Okay, so thank you very much for that one. Sharing this one. Okay, let me just stop sharing this one first. Okay, so now you still remember backs, yeah, how you do all the design process. Okay, so just a continuation for that. Let me just recap back on what is the design process. Okay. Oops. Okay. Right. For those for SEMO3512, this is just a knowledge from SEMO3512, but I need to recap back, yeah, just for your knowledge and just remind you, yeah, how fun and how tedious, yeah, the ship design process can be. Okay, so basically, the main approach, yeah, of ship design, yeah, is basically it categorized into 2, yeah, ship function and also payload functions. Yeah, the ship function here can be in terms of the structure. Okay, it can be also the crew facilities, the machinery. Yeah, it looks into the machinery, the tanks, yeah, the comfort systems, and also the outdoor decks. So, this actually the notes or the informations and details of this you can get from papan books, papan Nicolo books. There's a PDF on that, but I can share in the e-learning as well. This papan book on preliminary ship design. I cannot recall the full names of the book, but it's actually a comprehensive book that you can refer, on developing or basically the whole process of ship design, starting from the main requirements until all the elements in the ship design basically. Okay, so for ship function, so basically the main approach of ship design is the first one is the ship functions. Okay, so let's say one of the group, your main requirement is to develop or to design a cargo vessel. Okay, so when we have this cargo vessel, so we look into the ship function. What is the function of cargo ship basically? So based on that ship function, so we can come up with the structure. What kind of hull? Yeah? It can be V hull form, it can be U hull form, or it can be a catamaran or trimaran, whatever, based on the ship function. Okay. Then is there any poop or forecastle needed? What kind of superstructures? How many level of superstructures and so on. Okay, then you look into the crew facilities. Because it's a cargo vessel, so it should have this crew space. Because you're going to have crew on board your ship. Okay, then what kind of service space? You need to have the galley. Maybe you need to have they call it the mess room and so on to eat. And then you have this kind of a leisure room. And then the stairs, the corridors. What is the spaceway and so on. Then if let's say it's a cargo vessel, just now, so what kind of machinery? How many engines? How many pumps? All the steering, all the thrusters and so on. If let's say you are designing a naval vessel, so the engine should be a more powerful engine. Yeah. Here we also look into how many horsepower of the engine. How many horsepower to move at the required speed. And because if you look at the requirement just now, so you are given three owners requirement. You're given the ship type, you are given the deck weight. Deck weight is basically all the things that you bring on board. The cargo, the payload basically. And of course the speed. So based on that speed, you need to find the engine and all the machineries that can make sure that the ships operate at that required speed. Okay, then we look into tanks. What are the tanks should be on board a vessel? You should have these fuel tanks, loop oil tanks, water tanks, ballast tank, and voids for any purpose. Okay, then the rest lah. Basically, you have outdoor decks, comfort systems, aircon, and so on. Okay, that is the first approach. We design a ship based on the ship functions. Okay, then the second approach is more on the payload functions. Okay, payload function. If let's say you are given the requirements to design a cargo vessel, so basically we need to look into the cargo space. Okay, so how many hold? So how many hold you are given the dead weight just now? Let's say 50,000 dead weight tonnage. So how many holes that you need to have on board your vessel so that you can carry that payload, that 50,000 dead weight tonnage. That holes, Then you need to have this that cargo spaces, That the whole, this is the hole, Where you put all this cargo in the vessels lah. Okay, but then you also have this deck cargo spaces where you can put the deck, and this is especially for what kind of vessels on board the deck cargo. It's a container ship, right? So container ships, they need to have this deck cargo spaces. Is there any necessary for cell guides? If you are designing liquid, or chemical tankers, so you need to have a tanks for that one. To put basically your cargo is basically the liquefied natural gas or chemical or whatever chemicals liquid that you bring. Yeah, so basically what the cargo spaces here is more on the tanks. Okay. Then you look also into the cargo handling. Okay. For cargo vessels, maybe you can have just a normal crane, for example. But if let's say you are more on these vessels, apa tu, car, roro, or you are the livestock carriers, yeah, so you need to know how you're going to handle your cargo. Yeah, maybe you don't need to have these cranes, but maybe you need to have these apa lashings ke, atau maybe you have to have the ramps, yeah, to make sure that your vessel can go into the ship and can go out into the ship easily. Yeah, that one is for roro and for apa livestock carrier. Okay. The cargo treatment. Yeah, some cargo they need to have this ventilations, heating or cooling. Yeah, and maybe some will have to have this pressurizing. Yeah, based on what kind of cargo that you bring on board your vessels. Okay, so that is basically the main approach of design. So now, with that, with the given owner requirement, you have this design ship type, you have the deadweight tonnage, and you have the speed. Yeah, so basically you are more on the shape function and payload function. We cover both approach. Yeah, shape function is based on the ship type. Then the payload function is based on the ship type and also based on your deadweight tonnage. Yeah, so that is the main approach of designing a ship. Okay. Um, okay. I'm amused with those who comment in the Jamboard just now. It can be divided into two stages. The first one is designed and then the second one is built. Okay. Naval architects, they are more concerned in both stage, but you as a designer, you're most involved in the first stage. Yeah, first stage, which is design. You don't basically involve in the building. Okay, but sometimes you may involve, yeah, when you need to change something, then you are going to involve in the build stage as well. Okay, life of ship may be divided into two distinct parts, the construction period and also the operation period. Okay, so this is the most, I would say, important knowledge that you need to have as a ship designer. Yeah, so there are four main phases, but I don't think anyone put this one in the Jamboard just now. Yeah, and this is you should remember these four main phases. And I think in the test also we have asked you about these four main phases. Okay, so four main phases. The first one is concept design. Second is preliminary design. Three is contract, and also four is on detail design. Okay, can anyone explain to me the concept design? You can put in the apa in the chat box, or you can directly explain to me what is the concept design. Okay, we share knowledge with those your friend from SKMO. What is the what we do in concept design? What we do in the concept design or feasibility study? This is a questions in your first test, I think, last time, if I'm not mistaken. What we do in the concept design, basically. First sketch of our ship. What will it be? Okay, thank you, Daniel. First sketch of our ships. Okay, what will it be? Okay, anyone other than determine the requirements? Okay, so basically in your concept design or feasibility study, the preliminary design is where you determine the requirements. Or anyone want to answer before I explain? Oops. Have this one? Nope. Okay. Know what the mission, estimation, how can it meet expectation? Okay. Estimation of dimension, know which type of ship, capacity. Okay, so thank you very much. Yes, so basically, some of the tasks on the concept design, yeah, is also included. So they we call it basic design, yeah. So this one is more on combination. Okay, some of it is on the conceptual design, and some of it is what we call in the preliminary design stage, yeah. Okay, so for conceptual design, okay, of course, you have to identify the design requirements. Yeah. So let's say the design requirement, yeah, the owners of the ship come and see you as a ship design. They say that I want a ship that can bring um uh, that can bring, let's say, livestock carrier, yeah, that can bring cow, yeah, from New Zealand to Malaysia, for example. Okay, and I want it to have and I want it to put in the AC conditions. Yeah, the livestock carrier that some that usually at the moment there's no like aircon and so on, but there's a ventilations lah. Okay, but he said that he want an aircon with aircon, yeah, with aircon for the livestock carrier. Yeah, you put the cow, yeah, um in the box. It's not a box lah. What we call it? That one I cannot recall. Um, it's kind of box lah, yeah, on board the vessels. Uh, yeah, pen. Thank you very much. Okay, then yeah, with an aircon. So you as a ship design, you draw. Yeah, so that is the response from siapa tadi? Um, Daniel. Yeah, so you draw. Yeah, you sketch. Yeah, you first sketch of your ship. Yeah, so he said that he want to have an aircon. So you sketch. Okay, this is how it looks like. So this is I put this aircon. So maybe we can have this engine and what so on. Okay, so that is the first sketch. Okay, maybe if let's say someone come to you and ask, I want to build um apa a fisherman ataupun a fishing boat basically. Then that boat should be a modern fishing boat. Yeah, if you look at the current fishing boat that we have, they don't have this aircon, they don't have toilet and so on, unless for a big trawler going to the sea, big seas, and then they have lah this apa toilet. But some also don't have this toilet. But then this person, this owner come to you and say that I want to have toilet on board my ships. It's a modern design, maybe like aerofall or whatsoever. So you sketch that concept coming from the owner's requirement. Okay. Then that is what we call as a conceptual stage ataupun concept design. And from here, you do a feasibility study. A feasibility study more on the technical, more on the economics. Do you think that this is economic or not? Maybe if you, let's say, you want to design the livestock carrier with aircon just now, it is not feasible to do that. You cannot put aircon. Let's say, yeah. Then for the fishing boat just now, there's no room or there's no need for apa aero what I put just now aerodynamic design and so on. So there's no need for that. So you do that kind of feasibility study. It can be in terms of technical, it can be in terms of economics. Okay, so now with that, and then okay lah. I think the concept that I draw just now can be or doable basically. We can do it. It can works. Okay. So now with that, then you go into the preliminary design stage. So in the preliminary design stage, okay, what is the preliminary design stage? What are the tasks or the step that you do in preliminary design stage? If you remember on the design spiral, what are the preliminary design stage that you do, that you did last time? Yes, you determine the main dimension. Okay, so now you have the concept, you determine the main dimension. Then after that, what do you do? Determine main dimension. What are the else that you're supposed to do? Weight estimation, GA sketch, payload calculation, margin. Basically, margin is a part of process for selection of main dimension lah. Basically, okay. So now with that concept, Okay, with the owner's requirement, so you start with the main dimension. Because just now at the concept, you basically a concept, a concept, a draft. You don't have this main dimension, how many length, what is the breadth, what is the depth, and so on. Okay, so with that, with the owner's requirement, you start finding your main dimension. Okay, so main dimension LBDT CB. Yeah, there's a few methods that can be used, yeah, to determine the main dimensions. And from that main dimensions, let me just go to the next slide. Yeah, you have that main dimension. So now, and the rest of this is what you're going to do for preliminary design stage. Yeah, you're going to design the hull form. Okay, and previously in SEMO3512, you have analyzed, yeah, what kind of hull form that you're going to design. Am I correct? You're going to, maybe some of you going to use U form, U hull form, yeah, U shape hull form. Some of you going to use V hull form. Okay, maybe some of group they have this bulbous bow, but some of group they say that I do not need to have this bulbous bow. It doesn't increase the upper, it doesn't help with the keeping. It doesn't reduce resistance and so on. So previously, yeah, for the knowledge of our friends from SKMO, SMO 3512, we have done some analysis, yeah, on hull form. What is the suitable? What is the advantage, disadvantage of a hull form? Okay, you may look that part in, um, I think Daniel or someone have shared the link for Webex meeting or Webex recorded class for SEMO 3512. And all the link is actually named with the content of the lecture that time. So you can go to the specific Webex, listens if you want to, or you can uh, read in papan books. Yeah, what is the pro and cons for every hull form? Okay, what is the pro for bulbous bow? What is the pro for apa tu inverted bows and so on? Okay, then yeah, so basically with that hull form, basically you also refer to the basis shape. Yeah, basis shape is a shape that you refer to. Yeah, so last time I asked, yeah, uh, yeah, to start with your main dimension. Yeah, I asked you to search for shape that having almost the same as the weak tonnage of ship that are given to you based on your design requirements. Yeah, let's say your ship is 50,000 deadweight tonnage cargo vessel. Then you have to find a basic ships, yeah, or reference ships that having almost the same deadweight tonnage and ship type. Okay, so then they go and search for cargo vessel and that weight 50,000 deadweight tonnage. Okay, then we see the length, the breadth, the depth, and then the draft, and also the CB of the reference ships. Okay. Okay. So that's one way of determining the main dimension. But maybe that 50,000 that weight tonnage is not accurately 50,000. Maybe it's a 53,000 that weight tonnage, or maybe 552, 51. But you have, but very hard to get very close to the dead weight tonnage. Okay. Uh, but with that, you can estimate whether your main dimensions, yeah, your main dimension is supposed to be almost the same lah. If let's say 53,000 deadweight tonnage, maybe 150-meter length, so your ship shouldn't be more than 150. So it gives you some ideas, okay, on your main dimensions, right? So that one have covered in SEMO 3512. Okay, but do not worry for those our SKMO friend. We going to recap back that knowledge on next week. Okay. Then with that main dimension, you going to proceed with the next task, designing the hull forms. Now you're not going to just analyze the hull form, but you're going to design using Maxsurf or using Rhino. Okay, and once you design the hull form, get a very good design, mean that a smooth design, yeah, a good design, yeah. So based on that hull form, then you're going to calculate the hydrostatic. So do not worry, you're not going to calculate that one based on apa scratch apa semua, but basically you can use Maxsurf. Maxsurf can generate a hydrostatic properties for you. Yeah, provided you have a very good and smooth hull form. Otherwise, you cannot get a good hydrostatic properties. Yeah, so you can have your LCB, LCG, KB, KMT, displacement, whatsoever. Okay, that hydrostatic. But of course, uh, we cannot just simply get that from Maxsurf. I mean, you can get that directly from Maxsurf, but to assess your knowledge on hydrostatic, yeah, so you're going to use the knowledge from Naval Architecture 1. How do you calculate the displacement whatsoever? Then you're going to verify the calculations that you do manual with the one that you get from Maxsurf. Okay. We want to make sure that you are designing a correct formula, basically. The displacement is according to displacement that you need to have and so on. Okay, that for hydrostatic, you come out with the GA design. Okay, so GA design, there are some there are a lot of reference that you can use for GA design. Okay, what needs to be there? Okay, what is the size and so on. Yeah, so GA design. Okay, this is just a brief. I'm not going into detail on the GA, but the GA design, you can refer to any GA available. Yeah, with the same type of shape, of course. And there are also some rules that you can refer. Yeah, for example, you can refer to the NV rules. Yeah, for the watertight spacing. Yeah, watertight dimensions. Yeah, you should have how many watertight bulkhead. Yeah, for your ships. Yeah, if let's say length of 100 meter, the rules say that the NV rules. Yeah, the NV rules say that you need to have at least 5 watertight bulkhead. Okay, some part of it you can refer to, especially the sizing, yeah, the numbers, the dimension and so on. We have to refer to rules, yeah, the NV rules, apa Nippon Kanji rules, NK rules, or maybe you can refer to ABS, yeah, American Brewery Standard. Maybe you want to refer to Lloyd Register rules, yeah, whatever rules, yeah, you can choose whatever rules. Okay, last time I think I asked you to refer to Lloyd Register. Am I correct, that one? I think it's a Lloyd Register. Lloyd Register because it's quite simple compared to the rest of rules available out there. Yeah, it's a Lloyd Register, right? Or is it the NV? Lloyd. Okay, thank you very much. I thought it's the NV. Okay, it's a Lloyd. Yeah, Lloyd Register. Okay. Have you used this Lloyd Register before this? Is this the first time? I mean, is it SEMO3512 is the first time that you use Lloyd Register rules? Or have you been introduced to Lloyd Register in structure? Have you been introduced to Lloyd Register in the structure? Structure, I think it's structure 1, if I'm not mistaken. Or not? Or is it from ship design? Okay, right. Do not remember. Go say do not remember. Okay, I'm not sure. I think no. Okay. Yes, I think no. But basically, when you do structure later on IDP2, once again, you're going to um, revisit the Lloyd Register rules. A big ship usually refer to Lloyd Register. A small ships, a small fast craft, yeah, usually refer to DNV. Big ships, Lloyd Register is more simple. Um, Small ships, DNV cover more on the on the ship, designing the ship. Yeah. So some part you have to refer to rules. Yeah. Yeah. Stability ada sikit. DNV, IMO. IMO is common. So most of rules on stability they refer to IMO back. But for small ship we have this DNV for stability as well. Okay. Then from that GA design, you actually have to do the midship scantling design and strength assessment. Okay, a weight estimation and material takeoff. This 6 and 7, yeah, because it's require half of the semester to do that. Yeah, so that's why we don't cover in ship. IDP 1. We bring that one in IDP 2. But the process is almost like this lah. So you have the GA, based on that GA, you do the scantling. Yeah, the scantling is basically where do you determine all this structure of your ship. Okay. So you have the GA, okay, what to put? Maybe you have this bulkhead, maybe you have these stiffening members, maybe you have this blade and so on. So all that is basically, yes, girder, deck beam and whatsoever. So all this is basically in midship scantling design and strength assessment. This knowledge is coming from your ship structure 1, if I'm not mistaken. I do not know if the new curriculum is a bit different. Maybe in structure 2, I'm not sure. Okay. Wake estimation and material takeoff. From SEMO3523, you have learned the knowledge, the fundamental of wake estimation. Okay. But now you have the correct, or you have your hull form. So basically with that hull form, yeah, we're going to do the wake estimation and material takeoff for that particular hull form. Okay. These two require half of semester. Okay. Half of semester require these two parts. Okay, so skip that part for IDP2 later, next semester. So based on this GA, yeah, you have locate where is the tank, where is the cargo, where is this accommodation and so on, and superstructure whatsoever. We do the stability assessment. Okay, so we do the stability assessment basically to assess the stability of the ship lah. Okay, if not stable, then you have to rearrange your GA. So it the tedious works again. So you have to repeat. If your ship is not stable, then you have to repeat. You have to redraw your GA. So basically GA is draw later on in using AutoCAD. Yeah, you're not going to draw apa ni using manual drawing. Yeah, you're going to draw in AutoCAD. So then when you change, if let's say your stability assessment say that your ship is not stable, so then when you want to change the location and so on, it's easier for you lah. Okay. Then apart from stability assessment, what we do in preliminary is more on powering, yeah, systems design, but you're not going to cover on the system design. Yeah, basically system is a system itself lah, the electric system, the propulsion systems and whatever systems on board your ship. Yeah. Seakeeping and maneuvering analysis, we can do this a bit. Yeah. In the second half of semesters later, we can do a seakeeping. And actually there's, I don't put it here, it's supposed to be resistance analysis. Okay. This one can be run in the MAXEF resistance and MAXEF motion. Yes, thank you very much. It's a new names. Yeah, last time it's called MAXEF Seakeeper. MAXEF motion. You just directly put your hull form and we run the analysis with certain conditions. Yeah, just to briefly see the seakeeping behavior and also the resistance analysis. So we are not going to go into detail in this ship design IDP 1, yeah. But the fundamental or the knowledge you have learned in resistance and propulsion. So apa ya? Hydrodynamics, is it? Is it or dynamic of marine vehicles, right? For seakeeping. And of course, the costing and economic analysis. So this is we calculate the cost lah, yeah, not only the part for building, but starting from scratch, first starting from you get the concept, yeah, until the delivery of your design. Okay, so that is basically what we call as a basic ship design task. Yeah, it's a basic, it's not so detailed. Or you can also um, represent, yeah, the ship design process based on this, what we call as a spiral process. Okay, starting from mission, yeah, then we interpret into the function, yeah, get all the form, the mean dimension, the hull line, and so on. Then we look into the performance assessment, the resistance, propulsion, hull structures, and so on, and then economics until we get the final design. So it's a spiral process because why is it a spiral process? So if we look further into another, so this is also the same, another representative of ship design process, yeah, on the ship design spiral. Why we call it a spiral? Why we call it a spiral? Why ship design is a spiral process? Anyone want to answer that? Why ship design is a spiral process? Okay, I miss go said need to repeat many times. Repeats to get optimum results. So I combine their okay. I combine their answers. Just like the diagram. I combine their answers. So basically we repeat to get the optimum. To get the optimum design lah basically. Yeah. So let's say from this concept, yeah, you have come out with this concept and so on. You have calculate all these things. But when you go into, let's say, the stability just now, it's not stable. So basically, your concept at the beginning of the design process is not giving you a good performance, yeah, in terms of stability. So you have to go back. Yeah, you change the GA. Basically, when you change the GA, you change the ni the apa, you change the midship scantling tadi tu. You change the midship scantling, so then you go back into the stability assessment. Yeah. Maybe when you go into the midship scantling later on, yeah, you have determined how many stiffening members, yeah, maybe longitudinal, maybe transverse stiffening members, and so on. Okay, but when you calculate the weight estimation, yeah, when you calculate the weight estimation, it doesn't give you in term of cost. Yeah, it give you because you have a lot of stiffening members. Yeah, the weight should be higher. Yeah, should be higher. The cost should be bigger. So we do not want to have a bigger cost. Okay, should have an optimum cost. Yeah, cost effectiveness basically. Okay, so you have to repeat back. You have to do the midship scantling. So same, yeah, when you design the hull form later on, okay, you have designed, okay, but then, yeah, the displacement that you get is not the correct displacement as you want. So you may have to extend the length, or you may have to reduce the length, or maybe you have to widen the breadth, or maybe you make it smaller. So depending on what kind of error lah basically, when you face later on. So it's a spiral process. It's repeating until you get the optimum or um optimum or appropriate design. Yeah, basically. Right. So this is another representative of ship design spiral. This is for mission ships and for warships. Yeah, warship is more like they more looks into the weapon speed. Yeah, the environments, range, and the missions. Yeah, depend on what kind of missions the warship is built. Compared to mission ship, we don't look into that range. We look into range, but we don't look into mission. Yeah, and speed is not a necessary requirement, but for warship is a very crucial requirements. Yeah? Don't have weapons, yeah, operational rules, and so on. Okay, so you can look this one. you can read more on the Papan books. Yeah, all this is in Papan books. The detailed explanation is in Papan books, so you can read uh, through Papan books. Nah, okay. Okay. So I'm not going to go through all this, but basically we have to look into the technical, the performance, yeah, the technical performance and also the cost effectiveness. Yeah, when you design the ships, that are two important goals. Yeah, the technicality and the practicality. Yeah, um, the purpose and so on. Yeah, to meet the requirements. Okay, the reliability and cost effectiveness basically. Okay. Right. Uh, so this is the ship design process starting from requirement until building. Yeah, so like I put in the beginning of the slide. So basically this is the design part. Okay. And this is the building part. Right. So we have these two. So if you go into any yard, so basically this is how the ship design process is carried out. So starting from requirements, yeah, requirements, you do some studies, you come up with the concept, you come up with this sketch, okay. Then you look into all these tasks, yeah, the external in terms of the hull design, internals, yeah, general arrangement, the machinery, the system, and the structure. Then you do some analysis, the weight, the stabilities, the cost, and so on. Okay, so this is all the stage. So start with the concept, then you go into preliminary. Yeah, preliminary, which you come up with the main dimension. With that main dimension, you come up with the hull form, and then you do the analysis and so on. Once you have completed, or once you have find the optimum hull form with a good performance in terms of stability, cost, and so on, then this is the preliminary design stage. Where is mine? Okay, this is preliminary design stage. So we go into the contract design stage where you finalize, with the owners, the value of the contract. Okay, then from that contract design, okay, where you propose during the contract stage, then you give a functional design, okay, with all these elements. Okay, so then we go into the buildings or production stage. Okay, so usually in the production stage we have this transition design, okay, where you design the block. Yeah, because at the moment the practice of building a ship is on a block basis. Yeah, we build block by blocks or zone by zone. Okay, we don't build a full ship together. So we build block by block and then we combine together. This is a practice for big ship. Small ship doesn't matter. You can build one ship in a yard. Yeah. But for bigger ships, we build block by blocks. Then we combine. Okay. So with that, you need to have a build plan. Yeah. How to combine the blocks later on. Okay. Maybe a 3D model. Okay. And of course the material lah. Right. So I'm not going to touch on this production because you have learned this on ship and offshore productions. But basically, that is a recap of what is a ship design process. Okay, so once again, if you look in the spiral, it's a lot of work. It's a very tedious work. So you have to expect, you have to give expectations that you're going to do a lot of work in ship design. Okay, right. So I think that's about it for today. Hmm. Just to refresh your memory, how fun it is to do design. Ah. Okay, any questions? Yes. Any questions? Yeah. Fun after calculation part. Um, my advice, please manage your time wisely. Yeah. Um, you know, I don't think last time we have a lot of problems. I think most of you is okay. You submit on the dot. Basically, you submit by the deadline. Okay. So I hope the same with this SEMO3523 lah. Okay. It's a fun process. Yeah, you learn a lot, yeah, through this design process. And if you go into industry later on, especially if you go into yacht, yeah, you become a naval architect or a ship designer. Yeah, you apply all this knowledge, yeah, during that time. So it's a very worth, yeah, to spend a lot of time in this ship and offshore design project. Yeah, to see how lot of works. Yeah, previously it's a two subjects only, ship and offshore project. Sorry, ship and offshore design 1 and ship and offshore design 2. But the new curriculum we have 3, basically 8 credits, yeah, for the ship design only. See how tedious and how lot of works for ship design. But it's a fun process actually. So I hope you enjoy doing it. Uh, this semester is a bit, I would say, it's not so difficult lah. In IDP 2 is a bit difficult, but in IDP 1 is not so difficult. You have learned all these things um, in a previous, in other subject. Okay. So any questions? Nope. It's already 12:52. So I hope the rest or um apa ya? Siapa ya yang submit tadi? Maybe okay, maybe Daniel ya. Daniel can reshare again the drive, Google Drive tu. Saya pun boleh reshare juga nanti saya rasa. Okay, because some of them they join after you share that one. Okay, that Google Drive that Daniel share is on SEMO3512. So you can look if you want, yeah, and get this Papan and Watson book. Okay. So if there is no questions, then I'll see you guys on next week, Sunday. So basically next week is a crucial part for those coming from SKMO, yeah? Please attend next week. Do not skip the class. Erisha, your name is still not in the system, but you can scan the QR code lah. Okay. With that, thank you very much, ladies and gentlemen. I dismiss the class for now, and I see you next week. Thank you. Assalamualaikum and have a good day ahead.